All right, first question. So first of all, just the setup, what's happening here. We've got this graph, right? This graph is f of x, which is this function right here. And I've got the tangent line at point B. I don't know what point B is, but I know that line C is tangent to f at this point. And then this tangent line is going to cross the x-axis at point A. First, I just want to find the equation of the tangent line C. So I want to know what is the equation of this line when B equals root 3. So basically, when x is root 3, what is the equation of the tangent line? So that's going to be y minus, you need to find what y1 of, or let's just call it f of root 3 is. And you're also going to need to know what f prime of root 3 is for your slope. So we're going to go to our calculator. 6e to the x over 4 plus 1. Now I'm going to take the derivative, math 8, x, y1, calculating the derivative at root 3. So the derivative is 2.31284. And then I need the y value, so that's just y1 of root 3. And that is 10.251. And then now we're just going to write our equation, y minus the y value equals the slope times x minus root 3. So that would be the equation of the tangent line. You have to put at least 3 decimals. If you do not put at least 3 decimals, you're going to get it wrong. B is asking you to find the value of A when B equals natural log of 4. So now I am not looking at root 3 anymore, right? Now I'm saying B is natural log of 4. So if this is my B value, I want to find what A is. So first of all, in order to find a point later on the line, let's just find the equation of this line. So it's still finding the tangent line, but now I'm looking when x is natural log of 4. So I'm going to do y minus, we're going to look what f of natural log of 4 is, and f prime of natural log of 4. So same thing, I'm just looking, evaluating at natural log of 4 instead. (2.121) and derivative, that was the derivative. And now I'm taking this, finding the y value, not natural log of 4. We're doing natural log of 4. Okay. So my equation is y minus 9.485 equals slope of 2.121 x minus natural log of 4. Now, what I asked for was a value of A. That is not the equation of the tangent line. I'm going to need the tangent line, but that's not what I asked for. I want to know what is the value of A. A is the point that it crosses the x-axis, so I'm saying what x value will the y value be 0. So let's plug in y is 0. That's a minus, not equals. And I'm looking for what value of A makes this true. So then I divided 2.121 over from this. This is actually in times -1 now. And I'm going to divide, because it's 0. Well, I guess you could have done 0 minus this, or just times -1, doesn't matter. I'm going to divide the 2.121, but I'm not going to retype it. I'm going to pull down my answer from up here. So that gives me -4.471 equals A minus natural log of 4. And then to get A by itself, you're going to add natural log of 4 plus natural log of 4. And that gives me my answer is A is -3.0851. Alright, part C, I want to find the value of B such that line C has a slope of 9. So this right here, I want to know what x value would this have to be in order for the line to have a slope of positive 9. Yeah. So if I have a slope of positive 9, remember slope is just the derivative, so you want f prime of x to be equal to 9. And you're looking specifically for the x value B that makes this true. Now we don't actually need a calculator for this. If you look at your equation, f prime of x is just 6e to the x over 4 times 1/4. And if you're like, what are you getting 1/4 from? X divided by 4 is the same as 1/4 x. And then derivative of plus 1 would go away, so this is my f prime of x. This is equal to 9. Actually, I'm going to make the 6/4 just 3/2. Alright, and we're looking for this x value. If you want to call it b, it doesn't matter. Let's call it b. Now we need to get rid of the 3/2, so that's by multiplying by 2/3. That goes away. This is 18/3, which is 18/3, 6. So 6 equals e to the b/4. Now we need to get rid of the e, right? Whenever you have e to the something, to get rid of the e, you take the natural log of both sides. So I'm going to say natural log, natural log. Natural log of 6 is just natural log of 6. Natural log of e cancels out, and then just left with the power, b/4. And then lastly, to get b by itself, you multiply by 4. So this is 4 times natural log of 6 equals b. And that is the value of b that the slope of the line would have. Or sorry, the line would have the slope of 9. Right here, I am showing that it is continuous at x equals 0. So to show that it's continuous, I need to check both sides. So the limit as x approaches 0 from the left of h of x is just 1/2 0 squared or cubed plus 2 times 0 plus 1, which is just 1. Now I need to take the limit from the right side of 0, which is c times 0 plus 1. Doesn't matter what the value of c is, right? If you're multiplying by 0, this is just going to give you 1. And your h of 1 is or h of 0, why am I saying 1? H of 0 is this one, which we just said was 1. So the limit as x approaches 0 from the left of h of x equals the limit as x approaches 0 from the right of h of x, which equals h of 0. So h of x is continuous at x equals 0. Not at x equals 1. Sometimes I accidentally put the y value at x equals 0. Alright, if h of 2 equals 5, what is the value of c? So think about it. When x is 2, that's this one right here. So that would mean c times 2 plus 1 equals 5. Subtract that over. C times 2 equals 4, so that means c equals 2. Using h of 2 equals 5, so that means basically using c equals 2, and that h of 4 equals 32, are we guaranteed a value b on the interval between 2 and 4 such that f of b equals 10? So think about it. If we're trying to be guaranteed a value of 10, is that between these two values? So this would be intermediate value theorem, right? If I have h of 2 is 5, h of 4 is 32, somewhere between 2 and 4, I'm guaranteed all the values between 5 and 32. So I am guaranteed 10 between here. But only if the function is continuous on this interval. So let's look. From 2 to 4 would be in here. We actually haven't shown that this is continuous right here. So we first need to check, is it continuous at x equals 3? So I'm going to find the limit as x approaches 3 from the left of h of x. We're using c equals 2 because I'm using this value above. So this would be 2x is 3 plus 1 is 7. The limit as x approaches 3 from the right of h of x would be, that's 7. 9 times 5, I can do this. 9 times 5 is 45, minus 30 minus 8. This would be 15 minus 8 is 7. Good. So, this and h of 3 is the or equal to, which is 7. So this shows me that the function is continuous. So since h of x is continuous on the interval 2 to 4, there must be some b such that h of b equals 10 because, I almost put f, h of 2, because 10 is between these two y values and it's continuous, that between these x values you must have a y value that equals 10. And by IVT, the intermediate value theorem. Remember, your intermediate value theorem only works because h is continuous right here, and we showed that it was continuous by showing that the left limit equaled the right limit equaled the value. So that's why we knew it was continuous over here. Alright, if c equals 5, write a piecewise function for the derivative, so h prime of x. We're going to break down our derivatives. This derivative is going to be 3/2 x squared plus 2. The middle derivative is just going to be the value of c, because derivative of this is 5x, the derivative of 5x is just 5. And here derivative would be 10x minus 10. This is for x less than 0, 0 between x and 3, x greater than 3. Notice I'm not putting the or equal to signs here because I actually don't know if their derivatives match up, so it's not necessarily or equal to. It's very possible that the derivatives don't exist at 0 and at 3 if they're not equal on either side. Okay, and lastly I'm going to find h prime of 5. H prime of 5 is in this part. So h prime of 5 is just 10 times 5 minus 10. 50 minus 10 is 40. Make sure for your free response you're showing your work neatly and you're not writing any incorrect statements because you lose points for that.